Okay, on a previous video we had defined chemistry as the study of matter, and we had talked about how matter is anything that has mass and volume. Today we've got three objectives. We're going to basically look at all the different ways you can classify matter. The three objectives today are we're going to be able to differentiate between intensive and extensive properties. We're going to be able to differentiate between homogeneous and heterogeneous mixtures. And last but not least, we're going to differentiate between elements and compounds. So let's start by defining the difference between extensive and intensive properties. Extensive properties are dependent on the amount of matter present in whatever you're studying. So the more of this matter that you have, it will change the property. So for example, mass, volume, and length. If you have more of the substance, the mass will go up. If you have more of the substance, it'll take up more space, so the volume goes up. And if you have more of the substance or more of this substance of matter, then the length will increase as well. So just think of it this way. If you're trying to determine if something's an extensive property or an intensive property, ask yourself, if you were to obtain, let's say, double the amount of the substance you currently have, would it change the property? If the property's value changes, then it's extensive. Now, the opposite of this is intensive properties. And intensive properties only depend on the type of matter, not the amount. So it wouldn't matter if you had 3 times the amount of the sample you started with. These properties do not change or alter. So for example, color. If I was to double the amount of the substance I had, the color won't change. Boiling point, luster, and density. Luster is just simply talking about how shiny the object is. Density is a ratio of the mass of a substance divided by its volume. And no matter how large the sample size is, the density of a piece of matter will not change. Now let's talk a little bit about how you can classify a sample of matter. And this is something you'll see in a lot of textbooks. It's a flow chart. So at the top of this flow chart we have matter. And then we're asked a simple question. Can it be physically separated? So let's talk about what that means. If you have a sample and you can filter it and change it into its components, then you've got a mixture. If you can boil it and separate it into components, you have a mixture. If you can't do these things, then you've got a pure substance. So again, if you run it through a filter and you can break it apart into multiple substances, then you've got a mixture. If you can't do this, or you can't boil it or separate it by any physical means, then you've got a pure substance. Now, mixtures, there are 2 types you'll need to know. There are homogeneous mixtures and heterogeneous mixtures. And the way you determine the difference between these two is if the composition is uniform. And we'll talk about what that means, but that basically just means that it's evenly distributed. Now on the other side of the flow chart we have a pure substance. So let's say you try to separate the sample of matter physically and you cannot, then you have a pure substance. And there are 2 different categories this can fall in. It can either be a compound or an element. And the key question you'll want to ask yourself to determine this is if the substance, the pure substance, can be chemically decomposed. If it can, you've got a compound. If it can't, then you're looking at an element. And I'll break both of these down on the next few slides so you can kind of see how you can tell the difference. So let's talk about mixtures, heterogeneous and homogeneous. These are both mixtures that contain 2 different pure substances. And just to keep this as simple as we can, we'll call one of the substances orange and one of the substances red, since that's what the diagram's displaying. In a heterogeneous mixture, you'll notice that it's not evenly distributed. It's not uniform. If I was to take the top part of the heterogeneous mixture diagram, I would only be getting the orange substances. And all the red substances are at the bottom of the mixture. So this isn't uniform. It's not evenly distributed. However, in the homogeneous mixture diagram, you can see that the red and orange are evenly distributed throughout. So if I was to take the top part of the sample or the bottom part of the sample, I would be getting the same amount of each pure substance in the mixture. So it's all about how it's distributed. A good example on this for homogeneous might be salt water. So if I was to dissolve salt in water, I would have something called a solution, which is another term for a homogeneous mixture. And it wouldn't matter whether I took the top part of the glass of salt water or the bottom part of the glass of salt water. It would contain the same amount of salt regardless. Now for heterogeneous mixture, you can think of something like sand and water. So if I was to create a mixture of sand and water, most of the sand would sink to the bottom of the mixture. and I would have more water on top. So this is not evenly distributed, so it would be considered heterogeneous. The other part of the flow chart talked a little bit about compounds and elements. Now, compounds are going to be made up of more than one type of atom. So you have to have at least two different types of atoms in play, and they'll be bonded together. So in the top left of the screen, you'll see things like water, ammonia, carbon dioxide, and methane. And you can see that each color will have a different letter inside it, and that's going to represent a different type of element. So water is made up of two H's and one O, or H2O, and it's made of hydrogen and oxygen atoms. So two different types of atoms bonded together, that's a compound. Ammonia's sort of the same way. It's got three H's and one N. It's got three hydrogen atoms and one nitrogen atom. So it's made up of multiple elements. So it's considered a compound. I can physically separate these atoms. I can break these bonds and break them up into their components. That's what makes it a compound. Now, if you look at the bottom left, you'll see X and Y, two different diagrams. X just has 5 green circles on it. It's just one type of atom. So this is considered an element. And notice that none of them are connected. They're not bonded. So this is just simply a pure substance classified. It'd be classified as an element. Now, Y has two different types of elements. It has a green element, green atoms, and purple atoms, and they are connected. So this is a classic example of a compound. So sometimes these visual representations can be helpful. And on the sort of bottom middle of the screen there, you'll see element and compound, and it just mentions that an element is a single kind of atom, and a compound is bonded atoms, so at least two or more different types of atoms being present. So again, if we go back to our flow chart here, you can kind of see that you could take any sample of matter and put it in one of these bottom 4 categories here by asking yourself the questions on these flow charts. So hopefully this is helpful and this shed a little bit more light on classifying matter.